So in number one, I have to say that f is continuous on everywhere, but definitely on pi over 2, 3 pi over 2. In number two, I have to say that is differentiable, because sine is differentiable everywhere. Doesn't have a corner, a cusp, or a vertical tangent. And in 3, I have to find f of pi over 2, and I have to find f of 3 pi over 2. If they're not the same, Rolle's theorem is not applicable. So pi over 2 divided by 2 is pi over 4. So this is the square root of 2 over 2. 3 pi over 2. It's 3 pi over 4, which is still in the second quadrant, which is the square root of 2 over 2. So they're equal. Because of 1, 2, 3, Rolle's theorem is applicable, and I will write that by Rolle's theorem, there exists a C in the open interval pi over 2, 3 pi over 2, such that f prime of C is 0. Okay, so I'll find f prime of C. First, I have to find f prime of x, and which is cosine x over 2 times the inner function prime. And I set this equal to 0, so 1/2 in front, it doesn't matter. So cosine C over 2 equals 0, means cosine C over 2 is 0. And cosine is 0 when C over 2 is pi over 2, or C over 2 equals 3 pi over 2. From here, I have C equals pi, and from here I have C equals 3 pi. But remember, the interval is, so this belongs to, this is important, very important, to pi over 2, 3 pi over 2, and this one does not in pi over 2, 3 pi over 2. That's why this is so important to check. You cannot say, oh, this is guaranteed. No. It's guaranteed as long as it's in the interval that is given to us. But 3 pi is not in this interval, because pi over 2 is here, 3 pi over 2 is here, so the interval is this. So, hold on. So 1, 2, 3. I'm wrong. Thank you. I'm glad I graphed it. I'm wrong. Both of them are. Sorry about that. So it is in the interval. So I should have not erased the whole thing. Right? So this is pi, 2 pi, 3 pi. Both of them are. So in the interval pi over 2, 3 pi over 2. So there is a C1 and there is a C2. Both of them work. So between pi over 2 and 3 pi over 2, although it falls in the interval, it's not in the interval. Okay, I'm rushing now. Not in. It falls in the same between, but that's 3 pi is not in between pi over 2 and 3 pi over 2. Sorry about that. No excuse. I wrote it correctly and then I graphed it and I said, oh, no, but 3 pi is not in the interval pi over 2 and 3 pi over 2. It falls in the same area, but it's outside of the interval pi over 2, 3 pi over 2. Sorry about that. So that's why we always have to check. So you don't even have to graph. So 3 pi is 3 times 3 is 9. But this is pi over 2, and this is 3 pi over 2. So this is way outside of the interval. So 3 pi is not in the interval. So the only answer is pi. because pi is exactly in between. Although, again, 3 pi falls if you go around the circle, but who cares? It's not between pi over 2 and 3 pi over 2. So it's not in the interval. So there is only one answer, one C in this case. We can have more solutions than one, but not in this case. Good. Thank you. Sorry about that. I hope I didn't confuse you. So again, 3 times pi is 9 point something. This 9 point something does not belong in the interval 3 over 2 and 6 over 2. Is way outside. Is it okay? I hope I didn't confuse anyone with my gibberish here.
Makes sense to me.
Yeah, sorry about that. Good. Anything else? Are you going to be okay with a graph? Will you go back and look at all those graphs that we did in class together between now and Wednesday? Do you want me to scan this page as well with today's notes?
Yes, please.
Okay. I'll put it first in there. Is there anything else you would like to work on? So again, please remember, always check and write that you checked. Because if you make the error like I just did without thinking that that was outside of the interval, but if you wrote this, you will get points. So you do have to check that the value falls in the interval. If it doesn't, it's not guaranteed by Rolle's or mean value theorem. Anything else?
How many questions did you say is going to be on it?
Not more than 10. It's a short test. So some of you already told me you're taking the test, and the test